Hi, my name is Dai Matsuzaka, and today we're going to be working with Chapter 5.4, Angles and Arc Lengths. So, quickly, we have the circumference formula, which is 2 pi r. So if you're given a circle, say quickly, draw that. The radius is 2. What's the circumference? The circumference is the length of the line right here, the one that encircles the actual circle. Well, that is 2 pi times the radius, which is 2. So it's just equal to 4 pi. It's a quick calculation. You also have this on your formula sheet in the SAT. Now, what's the area formula? It's pi r squared. Likewise, I mean, if you have to, well, we have a circle. Suppose this is the radius of 2 again. Then what is it? What's the area? Well, I mean, we just have to find out what happens when you plug it in, right? 2 squared is equal to 4 pi. And you're done. So this is also pretty simple, and you're going to find this on the formula sheet as well. So no need to, sweat so much on figuring it out, deriving it, finding out what it actually means. None of that is really necessary. You just have to know how to do it, what to plug into the value of r. Now, we have something with the arc length and circumference ratio. And it's that basically the arc length divided by the entire circumference. I'm gonna shorten this. So I'm gonna say arc length written by arc and divided by the circumference, which I'll denote as circ, is actually an equal ratio with regards to its central angle. So the angle that is at hand divided by 360 degrees. So what are we actually talking about here, right? So the arc length, so suppose you have a circle again, right? We have, suppose, like a pi out of this circle. So let me draw that one more time. I'm going to draw it with red. That's not a great circle. Okay, great. So suppose we have a pi. Like so, this is the center. And I cut that out, right? So what we're saying is the angle here, this is called the central angle. The arc length refers to this segment over here of the circumference. The central angle refers to the actual angle that creates this little pi of the circle. And the circumference obviously refers to the entire red line here. So what this is just saying is that arc length, we'll just denote as arc, divided by the circumference, I'll denote as circ, is actually equivalent to the central angle, I'll denote as central, divided by 360 degrees. This is something that is very useful when you try to find basically the length of an arc. Because if you have the circumference, which you can get by the radius, and then you have the central angle, which might be given to you by the question, then you have all the elements necessary to find the arc length. Now, area of the sector and circle area also have the following relation with its central angle. So the sector area is basically, it's the same drawing as before. So suppose we have this pi, right? This is the origin. It's the center. So the sector area is right here, the whole piece of the pie, right? This sector area divided by the entire circle area, which I'll just denote as area, is actually equal, again, to the central angle divided by 360 degrees. So the same ratio that we were working with over here applies to the area as well. So how can you find the sector area? Simple. Find area, multiply it with the central over 360 degrees to get the sector area. We can actually equate all of what we have prior into a big equation, right? We can say that the arc length divided by the circumference, this ratio is exactly equal to the central angle divided by the entire 360 degrees. And this is also equal to the sector area divided by the entire area of the circle. So now you have three identities all equating each other. So you can actually do a lot of, it's like a puzzle where if you know one thing, another thing, and you can actually derive a lot of things because you have this equality that is chained. Now, let the central angle be 30 degrees with radius 1. We want to calculate its sector area and arc length. Now, this is simple because we already have the central angle, so it's 30 divided by 360. We have the area, right? Because we have the radius. What's the area? What's the area? Well, it's just pi, right? Because pi r squared, so pi 1 squared is just equal to pi. So that's the area. So if you just multiply this ratio by pi, this is actually equal to the sector area. You can verify this by looking at the equation from prior, right? If you just take the area, multiply it on both sides of this equation, right? Area times the central over 360 degrees is the sector area. Well, that's exactly what we have here. Area times the central over 360 degrees gives us a sector area. Done. The circumference is also quite fast, right? Because what's the circumference in this case? Well, 2 pi r, right? Well, r is equal to 1, so circumference is 2 pi, right? We want to know the arc length. Well, what do? Well, just multiply 2 pi times 30 divided by 360, right? Because this ratio, 30 over 360, is the ratio central divided by 360 degrees, which is equal to the arc length over circumference. So you multiply both sides by circumference, then you get arc length. This is equal to arc length. See how fast that was? Very simple. You just have to know this formula, this identity, to just draw out, identities about the arc length, sector area, whatnot. We have an alternate measure of angles. Before we use degrees, right, we go from 0 degrees all the way up to 360 degrees. And 360 degrees is like the full, circle. But, it's kind of poorly motivated, right? Like, what does 360, what does that even mean? Like, where did that number actually come from? Well, we actually have another measure of degrees and angles, which is called radians. And radians is actually a ratio, which is arc length over the radius. So if you think about an angle, right? An angle creates some arc in a circle, right? Which means that we can actually we can measure this angle by taking the ratio between this arc length over here divided by the radius, which is right here. And that gives us the specific degree necessary to create this sector. Now, radians and degrees are very closely related. Radians times 180 degrees over pi is equal to the degree. So, what's the, say we have the arc length of 2 pi. So it's just the whole circumference. And the radius is 1, right? In this case, because radius would be equal to 1 if your circumference is 2 pi. That means that you did 2 pi 1 squared, right? So your radius is equal to 1. Now, we have, what's a radian for 2 pi? Well, radian is equal to the arc length divided by the radius, so that's just 2 pi. So you have 2 pi to be the radian. So, what's 2 pi times 180 degrees over pi? It's 360 degrees. And 360 degrees was the entire angle fully rotated once. So that's how you can do radians and degrees, right? They're connected by this ratio right here, 180 degrees over pi. And next time I'll see you with the circle equations. Good luck practicing.